If someone told you that maths can describe the real world, safe temperatures, age limits, quality control, they were talking about inequalities. My name is Wendewessen Worku. In today's lesson, I am going to break down inequalities from the very basics all the way to compound inequalities, step by step, visually and in a way that finally makes sense. If you are new here, welcome. And if you have been here before, you already know what we do. We make maths simple. Before we dive in, hit that subscribe button and turn on notifications so you never miss a lesson. Let us get into it. The inequality compares values when the answer is not limited to one exact number. So they help describe situations like minimum ages, safe temperature ranges, and values that are too high or too low. This lesson connects the meaning of inequality symbols, the way solutions appear on a number line, and the rules for solving simple and compound inequalities. The main idea begins with reading each comparison correctly because the symbol tells whether a boundary number is included and which direction the possible answers go. An inequality is a mathematical sentence that compares two expressions by saying one is greater than, less than, greater than or equals to or less than or equals to the other. The symbol greater than means the value on the left is larger. So the statement x is greater than 4 allows numbers such as 5, 6 and 100, but it doesn't allow 4. The symbol less than means the value on the left is smaller. So the statement x is less than 4 allows numbers such as 3, 2, 0 and negative 5, but it doesn't allow 4. The symbol greater than or equals to and less than or equals to include the boundary number. So x is greater than or equals to 4 includes 4 and every larger number, while x is less than or equals to 4 includes 4 and every smaller number. A number line graph shows all possible solutions at once by marking the boundary value and shading every number that makes the inequality true. An open dot means the boundary number is not included, so it is used for greater than and less than because the number at the dot itself is not a solution. A closed dot means the boundary number is included, so it is used for greater than or equals to and less than or equals to 2 because the number at the dot itself is a solution. When the inequality says greater than or equals to, the graph extends towards larger numbers, and when it says less than or equals to, the graph extends towards smaller numbers. For example, x is greater than 2 has an open dot at 2 and shading towards larger numbers, while x is less than or equals to negative 1 has a closed dot at the negative 1 and shading towards smaller numbers. Solving a linear inequality means isolating variables while keeping the comparison true. Much like solving an equation, the balance rule says that adding, subtracting, multiplying or dividing the same amount on both sides keeps the relationship fair as long as the operation is handled correctly. The special rule is that multiplying or dividing both sides by a negative numbers reverses the inequality direction. This reversal happens because multiplying by negative 1 changes the order of numbers. Since 2 is less than 5 is true, but negative 2 is greater than negative 5. To solve negative 3x plus 5 is less than or equals to 14, subtract 5 from both sides to get negative 3x is less than or equals to 9. Having both sides by negative 3 reverses the symbol, so the solution is x is greater than or equals to negative 3. The graph of that solution has a closed dot at negative 3 and shading towards larger numbers because negative 3 is included and every larger value works. A compound inequality joins two inequalities with the word and or the word or, which changes how the solution set is understood. An and compound inequality means both conditions must be true at the same time, so its graph usually becomes the overlap between two boundaries. The statement 2 is less than x and x is less than 6 means x must be bigger than 2 and smaller than 6. So the solution lies between the two boundary numbers because 2 and 6 are not included in that statement. The graph uses open dots at both boundaries and shades only the numbers between them. A real range such as temperature greater than 20 degrees Celsius and less than 40 degrees Celsius is an end inequality because the temperature must stay inside one middle interval. An or compound inequality means at least one condition must be true, so its graph often splits into two separate regions. The statement x is less than 2 or x is greater than 6 includes numbers smaller than 2 and numbers larger than 6, leaving the middle values out. Because 2 and 6 are not included in that statement, the graph uses open dots at both boundaries and shades away from the middle in opposite direction. A rule such as a diameter less than 1 centimeter or greater than 1.5 centimeter is an or inequality because values from either outside range are accepted. Solving an end compound inequality with the variable in the middle means performing the same operation on all three parts of the inequality. For negative 5, for negative 5 is less than or equals to 2x plus 1 and 2x plus 1 is less than 7. Subtracting 1 from all three parts gives negative 6 is less than or equals to 2x and 2x is less than 6. Dividing all three parts by 2 gives negative 3 is less than or equals to x and x is less than 3. So the graph has a closed dot at negative 3, an open dot at 3, and shading between them. Solving an or compound inequality means solving each inequality separately and then combining the two solution sets. For 2x plus 1 is less than 5 or 3x minus 2 is greater than 10. The first inequality gives x is less than 2 and the second gives x is greater than 4. The combined graph has an open dots at 2 with shading towards smaller numbers and an open dots at 4 with shading towards larger numbers. A useful final check is to choose a number from the shaded region and substitute it into the original inequality because a correct graph should make the original comparison true.